Okay, Jim McGregor here from TIRIAS Research. I'm here with Craig. And Craig, we're at the Intel Technology Tour, and you had one of the best demos, which I think a lot of people don't understand yet, and that is RAG, Retrieval Augmented Generation.
One of the new AI buzzwords.
Exactly. Yeah. And 18 months ago, nobody knew what it was. In the last 2 months, everyone is referring to it.
That's fair.
And you actually had a great demo and description of it. So would you walk us through that?
Of course, I love to. And so the vehicle that we're going to take a look at and use is Phi. And Phi is from Microsoft, and it's a new version of LLM models, which we're calling SLMs, or small language models.
Open source model.
And this is an open source version that we have from Microsoft here. And so I'm able to take that and just imagine it as a smaller model that is meant to be running on smaller memory footprints and locally on your PC, like you would have on this AI PC here. And so that's great. So let's go ahead and see what Phi can do. And so Phi, as an individual model, has a great pedigree as far as in physics, mathematics, and coding. And so let's take a quick example, and I'm even going to go ahead and use my voice to go ahead and input this in. So really quickly, write me a function in Python. And just like that, it's done a speech-to-text translation. We're using Whisper for this portion of the model, and then it's easily able to use the leverage of the LLM or our Phi 3 model here, SLM, to be able to give us that great coding example. So that's one part of it, and two things have happened here, which is the GPU has accelerated the LLM. That gives us that super fast responsiveness, and this is all running locally again. And on top of that, we have the speech to text, which is done by Whisper, and that's running exclusively on the NPU. So we get a good mix of those two chips. But now let's go ahead and add something different in here. And so for RAG, which is Retrieval Augmented Generation, this allows us to add superpowers or to add existing knowledge onto the end of your LLMs. And why would you want to do that? Well, let me give you a quick example here. So let's say I wanted to ask my LLM what SKUs are available for Intel Core Ultra H series. And now when I go ahead and ask it this question, I get an immediate response back, but I will tell you that this response is wrong. And the best way to go ahead and make a LLM hallucinate or give you the wrong answers back is to go beyond its realm of understanding. And in this case, as you can kind of glean from the last sentence here, may have released more models since my knowledge cutoff date. And this is key. All LLMs have an end date to when they were finally trained, with Phi base model being end training in 2021. And so it doesn't even know what an Intel Core Ultra is. So how would they be able to give you that correct answer? So here what I can do with RAG is I can extend that knowledge base. And so what I can do is actually point it to a document, and I'm going to go ahead and point it to a Meteor Lake Intel internal document here to glean that knowledge. And while it's indexing this piece, it just finished it up. But this is all being done on the CPU side of this. So you see the CPU spike up to 100, and then that gives us our entire XPU story across the bit here. But now what can I do with this? So let's go ahead and enable this pipeline. I'm going to ask it the exact same question. And in this case, it's going to be using that data pool that I've used from that document to go ahead and answer this question. 4 SKUs, fantastic. And it actually gives us a rundown of the speeds and feeds on those. But also, because we have this retrieved document, we get a transparent look about where exactly it's gleaned that information. And I know that it's correct because I've given it a trusted source to go out there after it. This is my data. And because it's a private internal document from Intel, I feel safe and private by not having the bits ever leave my PC. So you can take an existing model today and extend its knowledge base by adding functionality like RAG.
So it's not only current, but it's customized.
That's exactly right. So that doesn't stop me from, I can go ahead and take this model today and take my personal financial data and turn it into my financial assistant. I could take my legal documents and turn it into my own personal lawyer, medical, my personal assistant, any of those things which I hold private, I know are not going to leave this place, but endlessly customizable for these new models. And as long as it's a performer, look at the kind of amazing focus that I can put to today's models, not just a general ask it any question, but something that's really tailored to you.
And something that's a lot less likely to hallucinate.
Exactly right, because you're asking it for that specific purpose. So again, this is all free and available today in open source. So it's something that anyone can play with, and truly one of the magic of AI today.
So that's impressive. But I think one of the most important things for people to take away from this is the fact that AI is not singular. Even doing a simple task usually requires several different types of workloads. And in this case, you showed it running on multiple different processing elements, which is why it's not all about an NPU.
That is correct.
About all the different processing capabilities that you have on an SoC or within a system.
Yes, that's correct. So I mean, currently we have those 3 targets, whether it's across the CPU, the GPU, and the NPU, but all of those have different purposes. So something that's really fast for inference, a really small job that I don't even need to heat up the driver on other cases there, CPU is your perfect target. But if I really want some muscle behind it, I want the most TOPS available on the system, which in this case for Meteor Lake is the GPU. And so I want that to be in the fastest resolving, just like I would have on my LLM if I wanted to have its fastest performance to get to that quick first to token answer. And then the NPU is excellent for long extended workloads. It's the lowest power target chip that we have on the entire platform. So anything that's long and extended that would normally crush your battery life, well, let's move things like speech to text. Let's move things like background segmentation from our video calls to be able to do that. And so having 3 different targets, as well as 3 different purposes for those targets across the XPU, that's the real value of an AI PC.
Craig, thank you so much. This is
My
a great
absolute
coverage
pleasure.
of not only Meteor Lake and Lunar Lake, for that matter, but also, you know, the benefit of RAG. So thank you.
Thank you very, very much. Have a great show.